At the MRS Spring Meeting 2022, the materials science community gathers in Honolulu and online to discuss new developments and research in materials science. The meeting program explores a wide range of topics from morphing materials to perovskites, photocatalysts, biomaterials, and much more. And MRS TV is right here bringing you all the latest from the meeting. Aloha and welcome to the Hawaii Convention Center here in Honolulu, and it is episode 2 of MRS TV 2022. Attendees are gathering for the second day in the spring meeting, and we're here to find out more about some of the key topics. We learn more about solid-state electrochemistry for sustainable energy technologies from this year's Kavli lecturer. Symposium X speaker Jennifer Dion explains how photocatalysts can improve the sustainability of chemical production. We hear more about new and exciting developments in material science from research organizations around the globe. The Mid-Career Researcher Award winner tells us more about her work into biosensing nanomaterials technologies. We learn more about the factors to consider when deciding between a career in academia or industry. And the MRS Innovation in Materials Characterization Award winner talks about her research on time-resolved carrier dynamics measurements. As you can see, we have an exciting program coming up. First, we're speaking to Cecina Haile, who gives the 2022 Fred Kavli Distinguished Lecture in Materials Science about vignettes in solid-state electrochemistry for sustainable energy technologies.
We recognize that climate change is an urgent crisis, and so there's lots of different technologies that we can use to address it. And the fundamental materials science is a really important step along the way of developing those technologies. I gave a kind of an overview, so I broke it up into 4 sort of areas in which we have done research and have made some progress in. So in one area, for example, using protonic conductors that allow, for example, ammonia to hydrogen conversion. That's a really important step as we think about a hydrogen economy. And we realize that, hey, wait a minute, we don't have the infrastructure. So ammonia is a nice fuel that you can use as a carrier for hydrogen. And so what we did was show that you can break the ammonia up on a local site and get high purity hydrogen that you can then put into a fuel cell. So that would get around the big problem of the hydrogen infrastructure. MRS, of course, is well known for the amazing meetings that it puts on, and so glad to be back in person and be at a meeting. And just allows for people to connect. And over the years, it's grown into a much broader set of impacts in terms of the many journals now it publishes, and the many, now through the COVID, learning about all the, webinars. How do we do that? How do we make sure that we are doing things beyond offering meetings, which is a good thing, but shouldn't be the end all. And so, MRS also, I think, really takes to heart the idea that materials are about making the world a better place. And it's really great to see that being embraced, and also viewing itself as a global organization and not, a US-based organization. I think that's also important in terms of bringing scientists together. I'm on the board for the African Materials Research Society, for example, and we collaborate with MRS. MRS has been really fantastic in terms of sharing best practices so that the African MRS can get, can learn quickly and be as successful as possible. And MRS has helped also with other activities. So I'm sort of a founding organizer of JUAMI, Joint Undertaking for an African Materials Institute, where MRS facilitates, information about this. So distributing the information, helping us find students who will apply to be part of this program. So a lot of different ways that MRS is acting as a global player in the materials research space and materials education space. And that's really incredibly important to me, as well as what it does in my sort of narrow professional area, which is, of course, incredibly important to me as well.
And joining me now is Jennifer Dion of Stanford University. Good to see you. Of course, you have an interesting topic, your talk, the light stuff, enabling sustainable product selective photocatalysts with Plasmonics.
Yeah,
okay.
kind of a mouthful.
Yeah, tell us what it's about exactly. And I know you talk about in your paper about chemical manufacturing really being a burden in terms of pollution and energy. How is this research important and impacting chemical manufacturing?
Yeah, great question. Well, if you think about many of the products we enjoy, upwards of 80% of all of the products we use come from a catalyst. So catalysts are usually small metallic nanoparticles that, expedite reactions and give rise to many of like the fertilizers, the pharmaceuticals, the fibers, like the plastics, the clothes, the cosmetics that we use. And yet many of these catalysts can only operate at high temperatures. So you basically need to elevate the temperature in order to be able to expedite the reaction and get the products that you want. And those temperatures, of course, come with substantial amounts of greenhouse gas emissions and CO2 that's generated. And in addition, like when you're using heat, it's almost like a chemical sledgehammer. So you're indiscriminately attacking like all of the bonds that you would want to break. So you're usually getting kind of a potpourri of different products. So today what I'll be sharing with you is our work to develop new metal nanoparticle catalysts that use light instead of heat to be able to selectively target specific bonds. So that way you can get not only a lot of the product that you want, but also enable kind of specific reactions to occur. So you're targeting specific bonds that you're breaking and forming. So that way you're, first of all, reducing greenhouse gas emissions, but then also getting more selectivity in your reaction.
Yeah, no, that's awesome. It's such a lot of advances and discoveries in this particular field. What do you think you are going to be focusing on in the future in this particular field?
Yeah, well, one of the cool things in the field is that when you're using light as opposed to heat, you're not in thermal equilibrium. You're actually out of equilibrium, and that opens up entirely new reaction pathways that aren't possible with just normal, like conventional thermal catalysis. So I think what we'll be focusing on, in the future is opening up new reaction pathways and reactions like carbon dioxide, reduction. I think, sequestration and storage of CO2 are going to be critical for, humanity's like surviving and thriving in the future. We're also excited to tackle problems like steel manufacturing. Steel manufacturing produces something like 8% of global CO2 emissions, so kind of critical construction materials. And then kind of moving beyond some of the more basic reactions my lab has done to things like plastics upcycling. So how you can create the circular materials economy rather than just putting plastics into landfill, actually upcycling them or kind of recycling them to enable the circular materials economy.
Yeah, a lot of applications. I know you're
definitely.
actually part of a new startup.
That's right.
Yeah, tell us about that venture.
Oh man, it's been so fun. So we incorporated our company, which is still in stealth mode, late last year. And we're able to acquire space earlier this year. We're venture backed. So if anyone wants to ask any questions about how to go after VC funding, happy to help. Kind of my lab's research at Stanford has broadly focused on this field of nanophotonics, how you can control light at the nano and molecular scale. And kind of the catchphrase for the company is enabling life speed reads of biological bits, which is a bit of a mouthful, but if you think about it, basically a snowflake size of biological material has over an exabyte of data. Like that is more data than like Google, Facebook or Meta, Amazon, Microsoft combined. And yet, like our ability to read these biological bits, whether it's nucleic acids or proteins or metabolites, is really slow. So there's so much data, that can tell us the secrets, of life and how we're operating and our health and transitions from wellness. And yet we're not able to unlock that potential because we have no good way of quickly reading out these biological bits like nucleic acids or proteins or metabolites. So the startup is kind of taking a lot of the insights that my lab has kind of pioneered in kind of directing molecules, but instead using them to kind of sense molecules and enable like faster reads of these biological bits.
Wow, that's super interesting. We're looking forward to seeing what comes out of that startup.
Thanks.
Congratulations on that.
It's been a great learning experience.
Yeah, and I'm sure people can contact you directly if they have advice. If you have great advice, I'm sure.
Yeah,
on
totally.
starting up businesses based on their work. So thank you so much.
Yeah,
Jennifer,
thank you.
appreciate you coming on with us.
Thank you so much. It was a pleasure chatting with you.
Now let's take a look at some of the latest developments in the world of material science. The Center for Sustainable Materials and Innovation at University of California, Berkeley is a new scientific and technological innovation hub aiming to solve some of the most pressing sustainable development goals around materials design and the circular economy.
The Center for Sustainable Material and Innovation started from the very core concept of how we think about material. And our goal is to have a radical shift in the way we design, we engineer, and eventually manufacture material to add the sustainability consideration into play. Today, when we make material, we think about the efficiency, the durability of the material, but there is no information about the sustainability figure of merit. So for example, how much energy it takes to reuse the material or recycle the material, and what is going to be the environmental impact. So with this center, we want to really rethink the way we make materials and have sustainability as one of the key parameters in the way we design them.
The Center for Integrated Nanotechnologies, a science national user facility, offers opportunities for students and researchers at its two New Mexico facilities, Sandia and Los Alamos National Laboratories. Let's find out more.
There is no better place to build a scientific career than a national user facility.
It's a really exciting environment to do research.
CINT stands for the Center for Integrated Nanotechnology. We have two facilities, one at Sandia National Laboratories and our Gateway facility up at Los Alamos National Laboratory.
This is a really exciting time for nanomaterials research, and that's because there's a demand for new materials at the national level.
To get access to CINT, all you need to do is write a 2 or 3 page innovative science proposal or nanoscience proposal that it's reviewed externally, and then once that proposal is accepted, then you're able to access all the capabilities at CINT for free.
What I really enjoy about being in this CINT environment is having experts in anything you can think of right around the corner from your office.
The Center for Rational Catalyst Synthesis is an NSF Industry University Cooperative Research Center at 3 universities with funding from 17 companies to do pre-competitive fundamental research to elucidate the chemical fundamentals of heterogeneous catalyst synthesis.
Catalyst preparation has been called a voodoo science. You have to use the right incantations and spells to get the right formulation. And so our goal in the Center for Rational Catalyst Synthesis is to turn the art of catalyst preparation into a science.
The opportunity to collaborate is a really important aspect of not only what we're doing in research, but the mission of Circus.
The whole concept is we do academic fundamental research that's driven by technological need and opportunity.
The Center for Rational Catalyst Synthesis is a wonderful place for people to develop new ideas and to cultivate new ideas.
At Tsinghua University in Beijing, research into flexible electronics has been at the cutting edge, focused on the design and fabrication of flexible integrated circuits. Let's take a closer look.
Our group has been working on flexible electronic technology for more than 15 years. More than 180 patents have been authorized. In the past Olympic Winter Games in 2022, we developed a wearable chest strap to help the athletes in monitoring the body temperature, ECG, and location in real time.
Flexible circuit manufacturing technologies produced flexible rotation monitoring system, conformally attaching these systems into rotation parts.
All the work we did required experts from different fields. We cooperate with them in a multidisciplinary approach.
Batch production of live demos from Tsinghua University can be realized in NFET with 8 small-scale pilot production lines. Tsinghua University and NFET will be the pioneer in bringing flexible electronics to common users, who will benefit a lot from this technology.
So joining me now is Molly Stevens, and she is the winner of the 2022 MRS Mid-Career Researcher Award. Congratulations, Molly.
Thank you. Thanks so much.
And I know you are having an interesting topic at the Lightning Talks, designing biomaterials to repair the body and detect diseases earlier. What can you tell us about that?
I'm going to be giving just a really quick summary of our group's research. So we're really interested in designing materials to interact with biology in interesting ways. And we cover both fundamental science, but also through to disease applications. And particularly interested in how we can use biomedical materials innovations to help with new delivery of new therapeutics, characterization of those systems, and also developing biosensing technologies that can be ultra-sensitive and detect diseases earlier.
Now, you talk about integrating assessments with smartphone technology for self-monitoring. How do we balance that?
Yeah, so one of the things I think that's quite interesting, and in fact we reported this in a sort of recent Nature paper, is thinking about how can you make technologies more accessible for everyone around the world, so including in low and middle income countries. And one of the things we looked at in Uganda, for example, was how many people could access technologies via smartphones versus via healthcare centers, and it's you can reach many more people if you can go out into the community, obviously, and have technologies that are cheap enough but also sensitive enough to be read by mobile phones. So the aim really is about democratization of access to healthcare, but of course we work really closely with groups also thinking about the privacy elements, and that is a really important point.
Yeah, I know we talked about the need for confidentiality and but having access to the data about who's being affected. Yeah. So it's a careful balance. Yeah. Where do we see this going forward then?
Well, I mean, we've seen it also in the current pandemic. It's really important to know where people, who's infected, where they are. I mean, maybe not their name, but at least be able to track how diseases are spreading within populations. And so in terms of thinking about the spread of diseases, and we did some work previously looking at Ebola serological surveillance. We published back in 2018, actually before the current pandemic. But, really understanding spread can help you come in with better interventions from a public health safety viewpoint.
Yeah, for sure. And, how soon do you think that some of these innovations will be able to be into the marketplace?
Oh, we have a number of different spin-out companies now that are either set up or being set up for different number of applications. So some of the technologies are, already tested with human samples and patients, and others are more sort of technologies helping in the characterization of technology. So, for example, we've just developed a technology called single particle automated Raman tracking analysis that can essentially help us with understanding the composition of individual nanoparticles. And that's really important for lots of drug delivery applications.
Mm-hmm. Definitely. And this is a Mid-Career Researcher Award. I mean, how do you keep your ideas coming, even with many, many years of experience?
Yeah, so I think the mid-career title is kind of interesting, actually. It's purely defined by age, as you probably know. So I'm still kind of young, even though our group has achieved a lot. And so the ideas really come from the whole team, I would say. We have a really open policy to discussing ideas and really encourage creative setting. And so I love being part of that process, but also nurturing all the younger people that go on to do wonderful stuff in our group, but also once they leave our group.
Yeah, wonderful. And no shortage of great ideas coming from the group also. So appreciate it. Thank you so much, Molly. Nice to meet you.
Thanks so much.
We're MRS TV, your daily news show featuring interviews and discussions on hot topics in material science from this year's MRS meeting. You can catch us around the convention center here in Honolulu, in select hotel rooms, on the virtual MRS meeting platform, and on YouTube. And you can join the conversation on social media. With new content each day of the meeting, make sure to keep on watching. Now we're catching up with Elisabetta Brugheri and Eva Hemmer, who tell us more about the factors to consider when transitioning from academia to industry.
So normally graduate students have an idea what academia looks like because they work in academia, but they don't have much of an idea what industry like. So we put together a panel of industry people to answer to this, and then a networking session for students to interact with the panelists. So hopefully the students can get more of insights from people in the industry and understand more what's the process, what's the transition like from academia to industry. What are the things to take into consideration? So your personality maybe, your skills, what are your career goals, salary, work-life balance, all these aspects that influence graduate student decision. I guess it scares them more to have like a 9-to-5 job. Then normally in academia it's not exactly like that. Academia gives you more flexibility probably compared to industry. So students might be afraid also of losing that. But at the same time, there's also a salary aspect to take into consideration. The hiring process that for industry is very different than for academia. So I guess it's kind of scary in all these aspects because there are many differences there.
As a professor, we can give like an overview and an idea of what are the pros and cons of academia, but most of us have probably never had any experience in industry. So it's much harder to mentor our students in that regard, except maybe from telling them, hey, take every opportunity that is offered to you. From an academic point of view, I think there is really, at the moment, it's very tough to find students. And I have seen several undergraduate students being really good in the lab and performing well, but they are kind of like saturated after the pandemic and the lockdown and so much time being at home that they feel like, oh, maybe I need a break before I go for grad school, and I may rather go with a real job in between. Industry has so much to offer for the students now to negotiate on salary, or maybe during the pandemic we have learned that home office is actually an option, so that this could be negotiated depending, of course, also on the style of the company. The Student Subcommittee is a great initiative that came up more than a couple of years ago now by the MRS. And we are working currently together with Laurie Smiley from the MRS, who is our liaison. And it gives the students an opportunity to come up with their own ideas, what is interesting to them in terms of seminars, webinars, events, online, in person. So they have really a voice.
It's a committee in which participate many graduate students, and there's also subcommittee chairs, which Eva is one of them, for example. And it's a great group because you can network with students that you didn't know before all around the world, and students come together to create these kind of events that are from students for the students.
So we had plenty of different events that range from online virtual events on like mental health and work-life balance during graduate studies, to today's event about bridging the gap between academia and industry, but also fun events like the famous PowerPoint karaoke. And this will also happen here at the MRS on Wednesday night, and it's definitely something not to miss.
So now joining me is the winner of this year's Innovation in Materials Characterization Award, Anna Maria Petrosa, coming from the Italian Institute. Your actual award cites your work in time-resolved carrier dynamics measurements. Tell us about the work.
Yeah, so time-resolved optical and electronic spectroscopy is already, I would say, established approach to material characterization. What we really did was trying to find a way to really characterize the materials in a real life condition. So the condition that you would find in working devices. So these help us a lot to really be able to picture the processes, the electronic processes in this kind of materials.
Yeah, so a lot of study needed to be done there. Now the talk that you're going to be doing is going to specifically focus on defects activity, and give us a preview of that talk.
Yeah, so one of the most curious, characteristic of this system that people immediately recognize was what is called the defect tolerance of this system. So these materials are processed from solution, but they show performances in devices which are not really those that you would expect from material processed in such a way. For this reason, have been called defect tolerant. This is for us as an important fundamental aspect, so understanding how the material could behave in such a way, and of course also applicative, as a strong impact in the application. And the defect, so the nature of defect really is key, is a key characteristic and property to understand why this material can be called really defect tolerant, and in which extent as well.
And we've been, like I said, we've been talking about the potential of perovskites for a while now. How close are we to it really being common in the market?
Yeah, this is a tricky question, especially for me probably, but what we can get from the people, we can see more and more companies getting interested in the material, so being less critical, and I see also companies who are more focused on established technologies like silicon, who are investing more and putting an eye on them. So in terms of stability and performances, the materials have been more and more encouraging. The results we got are more and more encouraging. So I would say that is on the good path.
It's on a good path. A little bit more years to. Is there any specific obstacles that you need to overcome?
Well, the stability, I think now is the core of the research, really, to make these materials more and more reliable and devices. So there is a very active research on that, both on the fundamental side, so understanding, for example, how defects are affecting the stability of the materials and the devices, the working process of the devices. That is probably the main subject of interest at the moment, to get them out.
Yeah, for sure. Well, we'll see. We'll be watching your work. Thank you, Anna Maria. Nice to meet you.
Thank you. Nice to meet you as well.
And that's it for our second day here at the MRS Spring Meeting 2022 in Honolulu. And we hope you've enjoyed our show today. Tomorrow, we will have more interviews with thought leaders and award winners, so make sure to tune in again. Before then, you can catch the show here at the conference center, in your hotel room, and online. And don't forget to subscribe and follow MRS TV on social media. We'll see you back here tomorrow.